In this video, I'm going to try and explain the process of translation, or turning the mRNA transcript into a protein. So, this is the process which occurs in the cytoplasm after transcription. And first of all, we need to look at the role of tRNA. So, tRNA is a type of RNA that brings the amino acid to the ribosome, and which amino acid is brought to the ribosome is determined by the code on the anticodon loop. So using the codon tables, you can work out which amino acid would attach here depending on what code you had there. One of the early phases of translation is called amino acid activation. And this is the process where the amino acids attach to the tRNA. This is an active process, so it requires ATP or energy, and it happens essentially all the time. So the tRNA attaches to the amino acid using ATP, and so that will then release ADP and P. Okay, so the process of translation starts with initiation, and in initiation what happens is the mRNA goes into the cytoplasm where the small ribosomal subunit will attach to it and will move along it until it finds the start codon. Once it finds the start codon, then it brings the large ribosomal subunit in, and the large ribosomal subunit has its three clefts, the A, the P, and the E. Remember the dancing monkey, and that is the direction that the tRNA molecules move. So that is A, that is P, and that is E. So once it has once the large ribosomal subunit has attached, then it's now a case of trying to bring in the complementary tRNA molecule. What will now happen is that the start codon would be here around the A site of the ribosome, and that will bring in the complementary tRNA with its attached amino acids. So if the codon was AAA, the anticodon would be UUU, and so on. Once the first amino acid is in the A site, then what happens is you get what's called translocation, and that first tRNA moves from the A site to the P site. So now we have another codon in the A site, bringing in a complementary tRNA anticodon with its associated amino acid. Now that brings the two amino acids close enough together so that they can form a peptide bond. Then the ribosome will move along again. So now we have a new tRNA in the A site, one in the P site, and one in the E site. Now what happens is that the one in the E site will drop off, and then all of these will then be able to shunt over one more time in this process that is called translocation. So you will then end up with this growing amino acid chain. Now that will continue until you reach what we call a stop codon. Now when a stop codon comes into the A site, what happens is that instead of a tRNA with its associated amino acid entering the A site of the ribosome, what happens instead is that something called a termination factor enters the A site of the ribosome. So then when it all moves on, what we then have is the termination factor in the P site, the last tRNA in the E site, that will then drop off, and now this is the polypeptide chain, which will then fold up and go and do whatever the protein needs to do inside the cell. And that is the process by which the mRNA transcript can be translated into a protein.